Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So in this video, I would like to do a summary about chapter 1. Okay, so this chapter is about dimension and vector. It's an important chapter. Okay, there's a couple of things you need to know about this topic. One is about how to do dimension analysis and whether you can determine equation is homogeneous or not. Another part is vector. So we're going to discuss the first part first because this one is the one that they might ask in exam. The vector part, they will ask you throughout the semester. Okay, how to determine dimension and unit. So I give you an example here which is false. This is a simple example. Okay, the main problem with students is that they got confused whether to put a square brackets or not a square bracket. So what I'm going to show you here on the right hand side is how to solve it. As long as you write anything before you substitute the dimension symbols, you need to put the square bracket. So example over here, first of all you have to write the equation according to the step there. So equation for force is F equals to MA. Okay, since this one is not a dimension yet, so you put a square bracket there. Okay, and then you substitute the symbol for dimension, which is mass. Now you don't have to put the brackets anymore, and this one is basically LT minus 2. Okay, so if you are not sure the dimension for acceleration, you can always trace back. You can always write the velocity equation, and then S over T, and then you can substitute back the dimension. So over here, this is the final answer. You can leave it like this. If the question asks you to find the dimension, if they ask you to find the unit, then you can write down. So therefore, the unit would be kilogram meter second minus 2. Okay, remember, if you write anything before the dimension, this is the dimension, you need to put a square brackets. Okay. Okay, for the next example, if you want the question want you to determine the equation, whether the equation is homogeneous or not. So you're given an equation, s equals to ut plus half at squared. So normally I would like my student to do the left hand side and the right hand side separately. So something like this, left hand side. Okay, this is the equation s, which is equals to length. The right hand side, you have the equation of ut plus half at squared. Okay, since this one is equation, so I'm going to put a square bracket over there. Okay, notice that I put square bracket even for the half there, which is a constant. And then notice that I put square for t square here. It's outside the square bracket. Okay, this one is equal to now I want to substitute the dimension. ut is basically lt minus 1. Oops, forgot to change. So this one is lt minus 1 multiply with the t, fine, and then this one is plus which is half at square. I can ignore the half because we only want to consider the dimension. So it will be lt minus 2 multiply with t square. Okay, now t minus 1 multiply with t can cancel out. T minus 2 multiply with t square can also cancel out. So we are left with L plus L. Okay, so since this one is the two term here, you can assume that that one is equal because this is equal. So you can say that the right hand side and left hand side is actually equal because this one is L, L, and L. Since left hand side is equals to right hand side, you can add, since the dimension of left hand side is equal to right hand side. Oops. Therefore, equation is homogeneous. Okay, this is an example of vector. So let's say if the question asks you to determine a vector, so there wouldn't be specific question in question 1, but you have to apply in the rest of the semester questions lah. Example over here, let's say if you have two vectors, one to the right, another one to the left. F1 is equals to 5 Newton and F2 is equals to 3 Newton. So this one, you can see that both of these vectors lies on the same axis. Okay, both of these in the x-axis. So this one is easy. To solve this one, F net is basically F1 minus F2. Why F1 minus F2? This actually, if you have a vector pointing to the right or upwards, it will be positive. If you have a vector pointing to the left or downwards, it will be a negative. So in this case, the 5 is positive because it is pointing to the right, and 3 is negative because it's pointing to the left. So you're left with 2 Newton as your resultant force. So here, if all your vectors lies on the same axis, you don't have to do resolving vectors. Okay, you can straight away add or subtract. Another example down here, basically now the force is moving a little bit further up. So F1 is somewhere in between x-axis and y-axis. Okay, so it does not lie on the x or y. So what you need to do is you have to resolve this one first. So when you resolve, you will have a vectors in this direction and in this direction, so that you can start to do addition or subtraction vectors. So I think I'm going to draw it. So this would be my F1x if you resolve it in x component. This would be your F1y. Oops. Draw it a little bit longer so that something similar to the height of your F1. This would be your F1y. You don't have to do anything with F2 because F2 is pointing in the x direction, x-axis. So for vectors, I strongly suggest you to use a table. So number 1, resolve in table. So you have two force here, F1 and F2. If you have more, you can simply add the row over there, and this would be my F net. Okay, so this one would be my F1x and this one would be F1y. Okay, F1, which is actually this vector, is equals to 5 cos 40. And this one would be 5 sine 40. Okay, why this one is cos? Okay, like I told you before, if you are going from the F1 and you want to resolve to the x-axis over there, it goes through the angle theta there, so that one will be your cos. So from here, you want to go over there, there's no angle, the angle is on the other side, so that one will be a sine. Okay, at least that's how I memorize things. I think I have to bring this one a little bit closer because we are running out of space. Okay, so if you use because 40 degrees is in degree, so make sure your calculator set in degree mode. Okay, and the answer this one will be 3.83. Okay, and then 5 sin 40, 3.21. Okay, before you go to the next step, always double check about the direction of this vector, whether it's positive or negative. Okay, in this case, f1x is pointing to the right. Okay, any vectors pointing to the right is a positive, so this one will be a positive. So, okay, if it is pointing to the left, you have to put the negative sign over there. f1y is pointing upwards, so this one is positive as well, so you guys are okay. So this one is okay. Okay, and then you're moving on to the next one. f2 you only have in one component, x component, so that one would be 3. Since this one is pointing to the left, you should put negative sign over there, and this one is a 0 because there's no vectors for f2 pointing in the y axis, tak ada, only in the x axis, so you only have x component. Now you can solve by summing up all the vectors in each column, so like this and this one. Okay, so this one would be 0.83, 3.83 minus 3, and this one would be 3.21. Okay, the next step would be find the resultant. The last step is to find the direction of the resultant vector. Okay, so F net here, my suggestion is always try to redraw these two resultant vectors, so you have fx net and fy net. Both of these is positive, so it will be pointing in this direction, upwards and to the right. F y net, f x net. Remember, for a vector, always draw the arrow. Okay, kepala dia tu jangan lupa. Okay, so the resultant vectors would be in this direction, obviously somewhere in between here. This would be my f net. And remember that I always told you that the theta would be always towards the x-axis, so that you can use tangent theta equals to y over x component. Okay, anyway, we find the resultant first. So this one really looks like a Pythagoras, so you have to solve or find the magnitude using f net, which is equals to square root of fx net square plus fy net square. That will be 0.83. So if you have a negative sign, you can substitute there. It doesn't matter because we take the square anyway. Don't forget the square root. Now press your calculator. About here is 3.32. So this is the magnitude of your resultant vectors. Okay, but you cannot stop here. because whenever we are talking about a vector, you need to write down the direction. You cannot assume it's going somewhere lah. So the direction would be, maybe I can write down this one as direction. Okay, as long as you put your theta towards the x-axis, so it will always be tangent theta equals to fy over fx, always be like this. Okay, so I already told you kenapa, so I'm not going to repeat that. Oops, I substitute straight away. I already show you why it becomes fy over fx from the triangle itself. So this one would be y, which is 3.21, divided by x, which is 0.83. Oopsie. You might be running out of space. So what I'm going to do, I'm going to bring this one a little bit further up. Okay. You just press your calculator. Okay, I got here 75.5. I might have to repress to double confirm. I still get the same. 75.5. This is a degree, so put a degree over there. Okay. Now, you need to write down the direction. So here, 75.5 degrees above, positive x-axis. Okay, so this one, maybe I can show you why it become above positive axis. Okay, this is a suggestion on how you can write the direction of your vector. So obviously this is just a suggestion, so anything that brings the same meaning should be okay. So you can see that over here, if the vectors is somewhere over here, you can write this one as above positive x-axis, which means that the angle theta here is above x-axis and in the positive because this is to the right. Okay, below and still to the right, so it's below positive. Above negative x-axis, so this one is your negative x-axis part, and this one is above and this one is below. Okay, so that's it I think for this video. Just a reminder that the dimensional part, they will ask you the question directly in question 1, but for vector you have to apply what you learned today indirectly throughout the semester. So make sure you able to do resolving vector, find the resultant and the direction. Okay, thank you for watching.